Welcome to a review for Management 370. Today we are going to finish Module 2. We have one more page. This page is about combining tasks. In our last class, we learned about how to calculate all the statistics, the wait time, the people in line for like a subway, so where there are multiple stations. But today, one of the workers at Subway called in sick. We have the bread, where you pick your bread, your toppings guy, and then your payment person. But unfortunately, the payment person called in sick, so we're combining the toppings and the payment queue. How are we going to find these statistics again? Well, our first question, which is question number 18 on page 9, if you have the packet. Question number 18 says, calculate the utilization for the new toppings/payment queue. Utilization is lambda over mu. We've been told that our lambda is 0.4. And then our mu, the way we found it last time was 1 over E of t, which we can still do. And if we have to combine two stations, let me show you like the little, we've been given this table where we have an E of t for both our toppings and our payment. All you have to do is add those two E of t's together to get the total time in minutes. It's pretty logical, which is cool. And that'll give us 1 over 2 minutes. So it's 4 divided by 0.5, or 0.4 divided by 0.5, which is 0.8. So the utilization or busyness for the toppings and payment queue is 0.8. Oh, you know what I just thought of? I wonder if you could just subtract the bread row, the bread utilization. Could you do that? Okay, let's find it together real quick. So we have row equals lambda over mu, lambda 0.4 divided by, because it's also 2 minutes in the bread queue. Oh. All right, I guess I thought it'd be inverse. I thought this might be 0.2, but I guess they're separate. All right, never mind. Thank you for going on that journey with me. So you cannot subtract it from 1, you just have to refine the utilization. So that's how you do problem number 18. And you can also, we also found the utilization last class of the toppings queue and the payment queue. You could just add those together if you wanted to check, and that'll give you 0.6 plus 0.2, that'll give you 0.82. I'm gonna put TP for toppings and payment. Question number 19 says, what is the average number of customers in the two-step process? All right, how are we gonna find that? By two-step process, they mean the bread and the topping and payments. So the average number of customers, how that's denoted is E of L. And all we have to do is add the E of L for the bread, so the average number of customers for the bread, to the average number of customers in the toppings and payment. It makes sense, like if you're asking how many customers are in the process, just add the two processes together. So we found this last time, the E of L for bread is 4. And then our E of L formula is row over 1 minus row. So all we have to do is 0.8 divided by 0.2, 1 minus 0.8, and that'll give us 4. So there's an average of 8 people in the two-step process total. All right, one more question. We are speeding along. How does an average customer, or how long, sorry, does an average customer spend in that two-step process? How do we find that? We are looking for E of W, which is E of L over lambda. And if this E of L is for both processes, all you have to do is plug it into the formula, So we'll go 8 over 0.4, which will give us 20 minutes. That's how long it will take at a Subway to get your bread, your toppings, and your payment. It feels like it's shorter, but that seems pretty accurate. All right, hope this helped.